So once again, to solve a quadratic equation by graphing, there are two ways to do it. You create a table of values, very time consuming, and you try to figure out a value that will give us 0 for the y coordinate. And that's the x, yeah, that's the answer for your x. Or to get it done quickly, you can use your graphing calculator and find the zeros on your graph. That's basically the x-intercept on your parabola. So here in example number 3, given we all know how to use a graphing calculator, we can then solve a quadratic equation that comes with decimal value. You can also use your graphing calculator to solve quadratic equations with big numbers that you don't like to work with, like rational number, fractions, decimal value. You don't like to do those with a table of values. So if you can turn this quadratic function into a quadratic equation, come back. You would then be able to solve for the x-intercept and find the solution. Here in example number 3, in a basketball game, the height of the basketball, a player shoots a basketball, and the ball travels in this way, in a parabolic motion. Let me enter this quadratic into my calculator first. I need to get back to the regular window, which I can do with Zoom Standard. You can return the window back to its regular by choosing this option, and we will see a parabola. This parabola describes the movement of your basketball. When someone shoots the basket, try to shoot the basket. But when it comes to word problems, there will usually be some restrictions that you want to be very careful with. We're talking about the height of the ball, and we're talking about the time. What are the restrictions in this case? Do you want to consider the entire parabola, or are we only looking at part of it? Are we using the entire parabola, or we are talking about some values that is possible? We're talking about the height. We're talking about the time. What are the restrictions again? Time? Cannot be negative. The time must be positive. What about the height? Can it be negative? Well, would it make sense when you shoot the basket? The ball probably will stay above the playground, so you want your height to be positive. So if I want to solve for the x-intercept, I will now be using y equals 0. So instead of working with the quadratic function, I will now replace the y here with a 0. Sub in 0 for y, turn it into a quadratic equation, no longer a function now. And this equation, once you solve it with a graphing calculator, once you get your calculator to draw the parabola like this one here, you would then be able to find the x-intercept. If it is to describe the time of the ball in the air, these will be the solution to your equation. And on my calculator, I can find the zero or the x-intercept by choosing a left bound, press enter, and then a right bound to find the point. This is one solution. We have another solution. Second, calculate the zeros. And find the root in between. If these are the x-intercept on your parabola, would you be using both numbers to solve these questions? Probably not, right? We're talking about time and height. We are not supposed to work with negative time. Oops, come back. We are not supposed to work with negative time. I want this point only. I don't want anything there. And your parabola wouldn't be using those as well. And in this case, we are only dealing with this and if you are using the x value to describe the time, what does it mean in this case? 3.13 seconds. Someone shoot a basketball, the basketball goes up, and then comes back, and then here, this is 3.13. And what does it mean?
How long it was in the air.
How long it was in the air? It takes 3.13 seconds to travel in air.